In this next video on graphing point, slope, and quadratic equations, we're going to look at the quadratic form itself. We'll consider the quadratic equation, the quadratic formula, which lets us solve the quadratic equation. We'll then go ahead and motivate that by solving it, and we'll then consider some properties that this quadratic equation has as it pertains to the form or the curve that we create in our xy Cartesian coordinate space. So first, the quadratic equation we think of traditionally as being y is equal to a times x squared plus b times x plus c, where we can then identify values for a, b, and c. These become important as we apply the quadratic formula to this equations so that we can solve for values of x. The quadratic formula, of course, is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2a. So let's think about what this is really going to tell us. As we solve this, then we're actually solving for values of x. This is not going to give us a graphic solution expressly to this equation, but it'll give us the values of x where this curve that comes from y equals a times x squared plus b times x plus c, it'll give us the values of x for which this equation exists or which we have as the curve crosses the x-axis. So we know we're going to end up with a Cartesian coordinate system of x and y, and we're going to end up with some shape that's got a curve, and in this case, as it turns out, it's going to be a convex shape, kind of like a U, and we're going to see that it's going to cross the x-axis in negative space. And so this will give us a little bit of interest here. This is a little bit different, as I said earlier, more complex than the linear equation of your basic point-slope form, but nonetheless important as we're thinking about shapes and curves and relationships within business and economics. So let's go ahead and select an equation, which we'll call that equation y is equal to 2x squared plus 4x plus 1. So this is the equation now, the quadratic equation that we will solve using the quadratic formula, and we'll talk about its properties, and then we'll go ahead and graph it with a table and such. So solving the equation. Again, my equation was y is equal to 2 times x squared plus 4 times x plus 1. And I know that I'll apply the formula x being equal to negative b plus or minus b squared minus 4 times a times c. All of that over 2 times a. So let me go ahead and begin to solve this. 2a. So then x is equal to, well, negative b, so negative 4, because here we have a being equal to 2, b being equal to 4, c being equal to 1. A, B, C, A, B, C. So as we go to solve this then, we can say that we have negative b, or negative 4, plus or minus the square root of, well, b squared, 4 squared is 16, minus 4 times a, or times 2, times c, times 1. And all of that over 2 times 1. Well, that gives us then negative 4 plus or minus, well, 16 minus 4 times 2 times 1, 16 minus 8 is going to be the square root of 8, divided by 2. Well, the square root of 8, if we put that into our calculator, we know that it equals 2.83 if I simply take it to the second decimal point. When you only go to 2 decimal points or 2 decimal places, you lose a little bit of fidelity in the value of the number, but it's going to be close enough for our purposes. So then I have that this is going to be equal to -4 plus or minus 2.83 divided by 2, which will give us 2 different solutions because we have plus, a positive solution, and we have a negative that will give us a negative solution. And as it turns out, this may not give us a positive solution, but we're using the positive operator to get to the solution. So -4 plus or minus 2.83 is -1.17 divided by 2, or that is equal to -0.585. And then the negative solution, -4 minus 2.83 is -6.83 divided by 2, so that gives us -415. So that helps us solve this for the equation itself. It hasn't really given us quite the definition that we might like as we think about solving y equals 2x squared plus 4x plus 1. All this did was help us solve for values of x. And if we think about this, I'll give myself just a little bit of space over here. Well, I don't want to get rid of any of that for you. I'll just put this right here. If we think about our Cartesian coordinate, we know that x and y, I've got 2 points along this, a point here at -3.415 and another point here at -0.585. And I believe now, having solved for these values of x, using the quadratic formula against a quadratic equation, I'm going to have a curve that's going to cross x at -3.415 and at -585. And as it turns out, knowing a little bit about this curve, it's going to look something along the lines of this. So let me go ahead and take a closer look at what defines that shape. So to do that, we're going to look at the properties. Well, the properties of the quadratic equation are such that as we see changes in a variable, it results in changes in a parabola. Well, we have a parabola here, or a curve that changes inflection once, because we have, which gives us essentially 2 sections to it, an upper and a lower, or a left and a right, depending on how you look at this, because this is squared. If it was a cube, then this would change and change again. If it was quad, it would change, change, and change. So the exponent is really what's indicating the number of changes in the curve. I have this down here for us, and gives us our basic shape. So changes in A result in changes in the parabola, its shape. Changes in A that are positively correlated with the width of the parabola. So as a positive A is going to yield a convex shape. So we had a positive A in our equation here. It gives us a convex shape. Convex is formed somewhat like a U. A negative A is going to give us a concave shape. So had this A been negative, we would have seen some concave shape, or a shape that looks like the opening to a cave. We know that changes in B will shift the parabola along the x-axis. So if we see changes in B, then we see that this parabola moves to the left or right, and B is positively correlated with the change along the x-axis. So as B increases, we see changes to the right, so x gets larger. As B decreases, we see changes to the left, x gets smaller. And then we see that changes in C shift the parabola along the y-axis. So the y-axis is going to shift it upwards or down. And again, C is positively correlated with the value on the y-axis, so as C increases in value, then we would find this parabola rising along the y-axis, and as C decreases in value, we would see the parabola shifting downwards along the y-axis. So let's think how we might plot this. We'll create a table of values to do this, to make it easy for ourselves. Since this isn't your basic straight line, it's a little harder than we had with the point slope equation. And I'm going to simplify this a little bit, and then I'll show you the completed table and show you how it graphs out in this particular or one particular equation. I'll use a different equation than the one we used here just to give us another form or another idea. So here we'll look at table of values and then we'll plot this. Well, to do a table of values, I want my x values and I want my y values again. And I'm simply going to identify some values. So I'll say, well, if we have x at negative 10, I'll say if we have x at negative 5, x at 0, and then x at 5. And we could fill these in with values in between, of course, but I'll have 4 different points here, which will give me some reasonable expectation of how this will plot out. So if I have x of negative 10, so then I'm going to say against an equation, and in this case I'll choose a different equation, and in fact it'll be a slightly simplified equation. I'll say that y is equal to 2 times x squared plus 3 1/3. Well, that doesn't quite look like this equation. I don't have a b times x, but in fact I do, because I have y is equal to 2 times x squared plus 0 times x plus 3 1/3. So this is the quadratic equation where a is equal to 2, b is equal to 0, and c is equal to 3 1/3. So let's see what this does for us. Well, so negative 10, if that's the value we have for x, then we have 2 times negative 10 or squared. That's going to give us a value, or plus 3 1/3 is going to give us 203.33. And if we then take negative 5, 2 times negative 5 squared plus 3 1/3 is going to give us a value of 53.33. And then if we simply have zeros for x, then that makes it fairly easy for us. We end up with 3 1/3 because 2 times 0 squared is simply going to be 0, and then we're going to have 3 1/3. And then if we have a value of 5, we'll once again be at 53 1/3. So you might think, well, why do we have the same value as we have negative 5 and positive 5? Well, when we square negative 5, it's the same thing as squaring positive 5. Negative 5 times negative 5 is 25. 5 times 5 is 25. So we end up with similar values on both sides of 0. So this is how we go ahead and fill out this table. Again, I've used a slightly simplified version of a quadratic equation holding b at 0 to just make this a little bit easier for us. But if this was fully articulated as the one we had a few minutes ago, if we had 2x squared plus 4x plus 1, you could also fill out this table of values. And when we fill out the table of values, if I go ahead and fill in those values in between and then plot them, it lets me see that I have this parabola. And in this case, the parabola is a little bit to the left of the 0, 0 nexus and just above the value of 1 at its minimum, so at its lowest point. And if we think back, as I increase a, it would widen this parabola. So as a gets larger, the parabola gets wider. As a gets smaller, the parabola gets more narrow. So as a gets larger, the parabola would come out like this. As a gets smaller, the parabola would come in like this. And of course, it's always going to have this exact same point down here. And then as b changes, positive b or increases in b will shift it to the right. Decreases in b will shift it to the left. And as c changes or the constant changes, it shifts upwards or downwards along the y-axis.